Good morning. This is Vasantha, Open Guest Lecturer, PG Department of Computer Science, St.Joseph College, Arts and Science College, Cuddalore. In this video, we are going to see about the sensors used in the Internet of Things. First of all, we are to know what is a sensor. Sensor is an input device which provides an output with respect to a specific physical quantity. The term input device in the definition of a sensor means that it is part of a bigger system which provides input to a main control system like a processor, microcontroller, or any other thing to the passing a control system. Another unique definition of a sensor is as follows: it is a device that converts signals from one energy domain to electrical domains. So examples of sensors, these are the sensors: color sensors, gas sensors, light dependent resistors like light sensors. Light sensor is nothing but whose resistance varies according to intensity of light it is subjected to. When the light falling on an LDR is more, its resistance becomes very less. When the light is less, the resistance of the LDR becomes very more. So this is some of the rain sensors, the prediction of raining, how much rainfall, which on the water flow sensors which is used in the dams, IR sensors which is used in the remotes, ultrasonic sensors, soil measuring sensors, humidity sensors, touch sensors, IR sensors. So many sensors. That's where we are going to see some of the particular sensors. So classification sensors can be done as active sensors or passive sensors. So active sensors are nothing that which require an external extension signal or a power signal. Passive sensors do not require any external power signal and directly generates output response. The final classification can be done in analog and digital sensors. Analog sensors which provides in a continuous output signal, just like a waveforms, it is provides as output. Digital sensors is nothing but which works with discrete or digital data, zeros and ones. It will give the conversions from a transmission, and it is in digital in nature. So there are different types of sensors: temperature, as we said, proximity, accelerometer, IR, pressure, light, ultrasonic, smoke, gas, touch, color, humidity, tilt, follow-on sensors. So temperature sensor is thermostat, thermocouple. A thermostat can be used to detect variation in temperatures. So it can be the humidity and everything can be measured using this temperature. It has a negative temperature coefficient. That means when the temperature increases, the resistance decreases. So the thermostat resistance can be varied with the rise in temperature, which causes more current flow through it. So proximity sensors. Some of proximity is a non-contact type sensor that detects the presence of an object without touching or anything. It detects the objects. So proximity sensors can be implemented using different techniques like optical, infrared, or laser, or ultrasonic, all effect approximation. Like we can see the mall, we can wherever we go, the door automatically opens. So this is used to use the proximity sensors. So some of the application of proximity sensors are mobile phones, car parkings, industries, ground proximity in aircrafts, etc. Infrared sensors, which is used in our remote controls and everything. So there are two types of IR sensors: transitive type and reflective type. Transitive type IR sensor, the IR and the IR data are position factor each, so that an object passes within them, the sensor detects the objects. So different applications where IR sensor is implemented are mobile phones, robots, industrial assembly, and automobiles, etc. This is a sensor which will be the IR sensors. So ultrasonic sensors, active ultrasonic sensor and passive ultrasonic sensors. The passive ultrasonic sensor is just for detecting ultrasonic noise which is present under specific conditions. So active means it will be under the gentle high frequency sound to be received back the ultrasonic sensor for evaluating the echo. The echo will be measured using the active translator sensors. It will passive sensors will score under specific conditions. So these are the automatic sensors which is used. There will be some pins, ground pin, trick, and echo pins. So it will be used for detecting the sounds. So chemical or smoke sensors. Smoke and gas detector is a carriage that sends gas, smoke, and typically it's an indicator of fire. Nowadays all secure devices using the sensor to passing signal to fire alarm, to control panel. Household smoke detector is also used as a smoke alarm. Most of these manufacturers using audible or visible alarm system in security devices detect automatically. So this is a chemical smoke sensor which is used for fire detection and everything. That is the humidity sensors. A humidity sensor or sense, measures, and reports both moisture and air temperature. The ratio of in the air to the highest amount of moisture at a particular temperature is called relative humidity. Relative humidity becomes an important factor when looking for comfort. So one of the real-time application of sensors is the autopilot system used in the aircrafts. The sensors sense the position, height, detects everything. In automatic flight control consists of several sensors for various types: speed control, height, position, doors, obstacles, fuel maneuvering, and many more. So the computer then provides control signal to different parts like engines, flaps, rudders, etc. That helps in a smooth flight. The combination of sensors, computers and mechanics makes it possible to run the flight. Okay. Computers and mechanics makes it possible to run the plane in a autopilot mode. All the parameters, the sensors and the mechanics are equally important to building in a automated sensors. Thank you for your